In this video I want to show you how you can invert a matrix by using the cross product. Let's take a look at the following example. The task is to find the inverse of the matrix A. The first thing we have to do is to transpose the matrix A, like that. Three over 3 plus 1, 6 minus 1, 5, 1. So we have put the first row of A in the first column, the second row in the second column, and the third row in the third column. I will now copy and paste this matrix here so that we have 3 identical copies. When you are applying the approach yourself, you don't have to write down this matrix 3 times. 1 time is enough. The only reason why I need the copies is that it is easier for me to explain you the approach this way. Now we have to ignore the first column of this matrix here, like that. And calculate the cross product of the still visible vectors. We will write the result in another matrix. Let's calculate the cross product. For the first entry of the cross product, we have to ignore this here and calculate -1 times 1 minus 6 times 5 is minus 31. For the second entry of the cross product, we have to ignore this here and calculate -1 times 6 minus 3 times 1 is minus 9. For the last entry of the cross product, we have to ignore this here and calculate 3 times 5 minus -1 times -1 is 14. Now we have to do the whole thing again, but this time we ignore the second column of this matrix here. I will use the second matrix for the calculation. So we have to ignore the second column. And then we have to calculate the cross product of the still visible vectors. So for the first entry of the cross product, we have to ignore this here and calculate 3 times 1 minus 4 times 5 is minus 17. For the second entry of the cross product, we have to ignore this here and calculate minus 1 times 4 minus 1 times 1 is minus 5. For the last entry of the cross product, we have to ignore this here and calculate 1 times 5 minus 3 times minus 1 is 8. One last time, but this time we have to ignore the last column of this matrix here. I will use the third matrix for the calculation. So we have to ignore the third column of this matrix, like that. And then we have to calculate the cross product of the still visible vectors. So for the first entry of the cross product, we have to ignore this here and calculate 3 times 6 minus 4 times minus 1 is 22. For the second entry, we have to ignore this here and calculate 3 times 4 minus 1 times 6 is 6. For the last entry, we have to ignore this here and calculate 1 times minus 1 minus 3 times 3 is minus 10. The next step is to calculate the scalar product of the first column of this matrix here. This is the first column, with the first column of that matrix. So the first column is this here. So we have to calculate the scalar product of this column here with that column, like that. Minus 31 minus 9 and 14 dot 1 3 4. This is 1 times minus 31 plus 3 times minus 9 plus 4 times 14. And this is equal to minus 2. We will now take this number here, minus 2, and add the inverse of this number as a factor in front of this matrix here. So the inverse of minus 2 is minus 1/2. And we will add this number here, minus 1/2, as a factor in front this matrix. The last step is to change the signs in the second column of this matrix here. So minus 17 becomes plus 17, minus 5 becomes plus 5, and 8 becomes minus 8. Don't forget this step. And now we have found the inverse of the matrix A, because this matrix here is the inverse of A. What sum the approach up? The first step is to transpose the matrix A. The second step is to calculate the three cross products, as shown in the last example, by ignoring the first, second, third column of the transposed matrix, and then write the resulting vectors in a matrix X. The third step is to calculate the scalar product of the first column of X with the first column of the transposed matrix. Let us call this number D. The fourth step is to multiply the matrix X with the inverse of D. Fifth step is to change the signs in the second column of this matrix here. Don't forget this step. Now you have found the inverse of the matrix A.